Okay, so we're going to start off today with the end behavior of a polynomial. What does that mean? Well, that means as we go to the far right of the graph or far left. Actually, far relative term away from 0 is probably a better way of saying it. Turns out, as we take a look at this graph, if we take another graph, let's say, or another function, let's just use, not just on a whim, the one with the term with the highest power of x, so the 5x cubed. And let's see what happens. Now, looking at this, we know there's going to be different values because the functions are different. Well, let's take a look. Here we go. So the red one is the original with all the other terms. The blue one is just the 5x cubed. Now you can see, yeah, we're pretty close to 0, plus or minus 1 in here. There's a significant difference. This is negative, that's positive at 1. But let's start to zoom out a little bit. So at 2, yeah, it's much different. At negative 2, well, we can't see that yet. Oh, there it is. So, yeah, that's different. That's going to be a difference of 10. Well, 10 and negative and 40 or negative 40, that, yeah, okay, that's a difference. And the same thing as we look over here. But let's really zoom out. Let's get further and further and further away. Now, notice how we're not even at 10 yet. Look how close those suckers are together. And look how far we go. So I'm zooming up, 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 up. Even if I would try to zoom in here. So here's 5, here's 10. So we're only at 7 here. And in 1500, it's, yeah, 100 apart. You can state that really doesn't make a difference. There's a very slight difference, but the big part is that they're mimicking each other. And it's only that leading term that has the effect. So we can only look at this. Now we can describe this as our left-hand behavior. And of course our right-hand behavior. Now as I remembered back from the graph, at the left side this went all the way down, was heading downward, so that was heading towards negative infinity. And at the right, when we were scrolling, it would head up towards positive infinity. Two things. One, we don't like writing this out mathematically, so there's got to be symbols. We'll get that in a second. Otherwise, we could just even figure this out by looking at it. Take a big negative number and cube it. We get a really big negative number, times 5. Whoop-de-doo, it's still a big negative number. Big positive number, cubed, is a big positive number, again, times 5. Again, when I'm thinking big, I'm thinking 100 million. Even go 100 cubed is darn big, times 5. So that's all we can do. Now, the way we write it mathematically is use what's called this limit notation. The limit notation uses a limit. Here's the notation. Limit as x with an arrow or approaches something, a number, a value. In this case, it's not going to be a number because we're dealing with behavior. And then a function. And it's equal to something. Now, we can write the function, we can write the whole thing, or the name. Either one. We'll get more involved in that toward the end of the semester. So, for our left-hand behavior, the limit as x approaches negative infinity. So that's all the x's going far to the left of f of x. Equals where? Negative infinity. And our right hand behavior, limit as x approaches, it gets closer and closer and closer to negative infinity or positive infinity. It ain't gonna happen. With f of x gets to positive infinity. Now, thinking back to where we did just looking at this before, we could actually create a quick little table to get the end behavior and just to get a table of this so we know what happens. So with the leading coefficient, so if the degree is odd, something's going to happen. When the degree is even, common thing's going to happen. Now your leading coefficient, in other words, what's the coefficient of the term with the highest power? So we'll draw a little for pretty close. So when the leading coefficient is positive, as we looked at before, that was what we had before, the 3x cubed. So the x cubed, it was an odd degree. 5 is a positive number. What ended up happening, as we saw before, our end behavior were opposites. They went in opposite directions. So the left-hand behavior of the function was negative infinity, and the right-hand behavior, so the limit as x approaches positive infinity, was positive infinity. Now what happens if that was a negative leading coefficient? Well, we would switch the directions. So we'd take that super big negative number that we cubed or fifth power or whatever, so it's even a bigger negative number, times a negative, negative times negative, positive infinity. And I put the positive there just for effect. It's not necessary. And so what happens when we go to positive infinity? Go to the right. Again, super big positive number times how many times itself, it's still positive, times a negative coefficient, negative. So even, well, if opposite was odd gave you opposite ones, evens gave you equal. Well, that seems familiar. I think we heard that before. So now, what happens when we take any number, any real number, and square it for even number of times, multiply it even number of times? Yep, we get a positive value. So that means both our left-hand behavior and our right-hand behavior are both positive infinities. What happens when we multiply by a negative coefficient? Well, multiply a positive number, any positive times a negative is exactly negative infinities. Okay. So let's put this into use here. So leading term is 3x to the fourth, highest power of x. So degree is 4, which is even. Our leading coefficient is negative. So that means our left and right hand behavior So left-hand behavior, limit as x approaches negative infinity of f of x. Our right-hand behavior, so limit as x approaches positive infinity to the right of the graph. So we know because of the even degree, they're going to be in equal or the same direction. Now, positive or negative? Well, leading coefficient's negative, means we're going to take those positive powers, positive things, and multiply by a negative. So on the graph, it's like dropping like that on the grid. Let's work through the same thing. Leading term, highest power of x, degree 5, odd. Leading coefficient, positive. So, left-hand behavior. So the limit as x goes to infinity of negative infinity is f of x. Limit as x approaches positive infinity of f of x. So we can revert right back up to the chart. Odd degree, positive leading coefficient, goes from negative to positive. We could even just process it out. Negative number to the fifth is a negative times a positive, and it's really big. Positive number to the fifth power is a big negative, positive times a positive. Boom. There you go. Now, how about graphing those? This is actually, what do we do with this? Well, we get the zeros and multiplicities. By the way, the multiplicity just tells you the number of times the zero occurs. So here, how do we set it up? Well, first of all, we need to set up our end behavior. What's our degree? Well, how many total powers of x? So we got x here, x squared, so there's 1, 2, 3. Now your leading coefficient might be a little bit stranger to see here. Well, look at what happens when we take x times x squared. That's another way you can get your degree. Well, this is going to be a positive 1. So we know our end behavior, odd degree end behavior, is going to look, when we get to the graph, to the left here is going down towards negative infinity, right here positive infinity. Well, what is the zeros? So what happens when f of x equals 0? Well, 3 here, negative 2 here. But wait, what happens with that square? Well, that square means this has a multiplicity of 2. An even multiplicity does something strange on the graph. Now, we don't have to be too precise. Just this is good enough. So here at 3, and here at negative 2. So our end behavior, left-hand behavior is this, right-hand behavior is that. What happens in between? Well, think about it like this. If the zero is a door, and you go through a door twice, you're going to end up at the same place. So you're not going through it. But with the odd multiplicity 1, you go through. Okay? We'll take a look at the next two at the next graph, next video.